And what I hope to do tonight is to talk a little bit about where we are today with the science, what we understand about the dangers. It's much different from what we understood a year ago. And it will be much different from what we understand 6 months from now. So what I'd like to do first, to give you some context, what I'm going to be talking about is to direct your attention to the two screens. I bet you thought that was just psychedelic film. Well, actually, what that is animation of the life of a cell. And while you're listening to me today, that stuff is going to actually occur hundreds of thousands of times in each of your bodies. Now, a couple of things I would like to point out. And the first is that when everything is working right, the body is an enormously beautiful machine. But when things are not working right, we have disease. And there are a couple of things here that I would like to have you focus on and remember so that I can refer to them during the talk. Okay, these things here, those are microtubules. See those little connections between those two cells? Those are microtubules. And when everything is working right in a cell, you have two types of communication that occurs between cells. And as Alfred eloquently mentioned this afternoon, you have cells that communicate and talk to each other. And when they talk to each other and work together, they form a tissue. And when you have tissues that talk together and work together, you have organs. And when you have organs and tissues that talk together and work together, you have an organism. And we as human beings are an organism. And it is all based on the ability of cells to be able to communicate with each other. Now, these two different types of communication between cells involve microtubules and gap junctions. Now, microtubule communication is instantaneous energy communication. It occurs at the speed of light. That's why when you stub your toe in the night, you feel it instantaneously. That is because there is instantaneous speed of light energy communication going through microtubules from your toe to your brain and back to your toe instantaneously. So microtubule communication is the energy communication. Now, when things work properly, what happens is that the microtubule communication occurs first. And it tells the surrounding cells that something needs to be done working together. Something needs to be done. The microtubule communication is instantaneous, and the something that needs to be done is communicated through something called gap junctions. And that communication is chemical, and it's slower, and it's the big job communication. So microtubule communication occurs first, and then the big job gap junction communication occurs second. Now, you can turn that off now. Subtle energy interventions operate at the microtubule level. They operate at the microtubule level. So that what Alfred was talking about earlier today with the energy resonance technology, the target is microtubule communication. And when things are working right, if microtubule communication is efficient, then gap junction communication follows behind it. So if you handle microtubule communication, now you're handling everything that follows. That's when everything is working correctly. The difficulty is that with energy systems that go from cells through tissues, through organisms, the biofield, and you have external energies that compete or interfere, things are not going to be working properly. Now, over the past 20 years, scientists from around the world have studied very precisely what happens in the electromagnetic spectrum in terms of mechanisms of harm to organisms like human beings. It turns out that all electromagnetic radiation is not created equal. There are at least 3 different effect windows that operate through different mechanisms. One effect window has to do with extremely low frequency radiation, the type of radiation that comes from electric power lines, the type of radiation that you have in leakage in your home. And the mechanism of harm there is direct magnetic influence. At the other end of the spectrum, you have another window that occurs with ionizing radiation, X-rays and gamma rays. The mechanism there is high energy breaking of chemical bonds, so that in the ionizing radiation part of the spectrum, there's so much energy that it can directly break DNA and other chemical bonds. Now, because we have understood those 2 effect windows for almost 100 years, the assumption was made that radio frequency radiation was going to operate through the same mechanisms. That is why in the early 1980s, when cell phones were first introduced in Europe in 1981, in the United States in 1984, they were exempted from pre-market safety testing. And the reason was because the industry convinced the government regulatory authorities that the mechanisms of harm from radio frequency radiation were direct magnetic or ionizing. And based on that, cell phones and subsequent wireless technology went into the marketplace, never having been tested for safety. Never having been tested for safety. Now, in the ensuing years, everything was fine with that decision until Larry King Live ran a show with a fellow by the name of David Reynard, whose wife had died of a brain tumor, and she was pregnant. And during her pregnancy, he bought her a cell phone. And her surgeon, David Perlmutter, believed that the tumor was related to her cell phone use, because the tumor was a very unusual tumor called a neural epithelial tumor. It was a type of tumor that started on the outside of the head and grew inward. He had never seen one of those before. So that he went on the Larry King Live show with her X-rays and showed that the pattern of her tumor was the pattern of where the antenna from the cell phone was. Now, the next day, Motorola stock went down by a few points. And 2 days later, the industry held a big press conference. And at that press conference, they reassured the public in no uncertain terms that there were literally thousands of studies that had been done to prove that cell phones were safe and that there was nothing to worry about. And the media said, well, that's good news. Where are the studies? And they didn't have any. And they tried to show the media studies of microwave ovens. And even the media could figure out that you don't put a microwave oven next to the side of your head. So what happened was congressional hearings were called for. And during those congressional hearings, it became clear that cell phones had not been tested for safety, that we had no idea whether or not they were indeed safe. There were 15 million Americans and about 50 million people at the time around the world using cell phones, and we had a problem. So the industry stepped up to the plate and said, we'll put what became $28.5 million into a research fund. And that research fund will be used to study the safety of cell phones. And the deal was that if the government doesn't regulate us until the research is done, then we have a deal. And of course, that deal was struck. This big program was put together. I was the person who they gave the $28.5 million to. We went forward and did work. Now, let's jump ahead to today. Today, we have 2 times 10 to the 9th people using cell phones, which is 10 to the 9th less than a gazillion. Okay? So it's a whole bunch of people. Where's John Williams? You'll get there, partner. Don't worry. So we have 2 billion people now using a technology that we don't yet understand completely about safety. Now, what we know is that radio frequency radiation is unlike any other type of radiation that the human organism has ever seen. So that we have not been able to adapt a compensation mechanism to protect us from electromagnetic radiation. And that is electromagnetic radiation in all 3 effect windows. What we know is that most wireless communication has carrier wave frequencies in the 1900 to 2000 megahertz range. Now, your heart beats at 2 hertz, 2 cycles per second. 1900 megahertz is 1900 million cycles per second. That frequency oscillation is so high that biological tissue cannot recognize it. So that on that basis, radio waves in and of themselves simply pass through human being without doing damage. The problem is that those radio waves don't exist in nature, and the only way they exist in real life is with information on them. With information on them. Now, when I was a young boy, my mother had a clothesline that was on pulleys. So you pull the clothesline and the clothes would go out, and then you pull it back and the clothes would come back in. Now, the way the 1900 megahertz carrier wave works is like that clothesline. It is the clothesline that carries the signal from a cell phone, from a PDA, from a wireless computer hookup to a base station. So that is the clothesline, the carrier wave. But your body can't see the clothesline. Now, when you put clothes on the clothesline, it is the equivalent of putting data packets on a carrier wave. Because it's necessary for information to be interpreted from your cell phone to the person who's answering the phone at the other side. In order for that to happen, information is put in packets, and those packets are put on the carrier wave. And it's the equivalent of having that clothesline full of clothes, and you pull it rapidly. And as it's moving through space, those clothes start to wave back and forth. And that's exactly what happens with the information secondary wave. It begins to oscillate on top of the carrier wave in the Hertz range, and that can be recognized by the human body. So that the first take-home point is that the danger comes from information carrying radio waves. Anytime you have a communication device that is sending information somewhere, it is packeted information. And that packeted information forms a secondary wave that is recognized by the body. Now, how is the information recognized? Well, it all goes down to the cell. And the cell membrane has protein sensors on the outside of the cell membrane that vibrate. And when this information-carrying wave comes in the vicinity of the vibrating protein, they communicate with each other. It's like the dueling banjos song. The incoming wave goes da-da-da-dum-dum, and then the protein vibrator goes da-da-da-dum-dum, and then the other one goes da-da-da-da-da, and then the protein thing goes da-da-da-da-da, and there's recognition. So that for recognition to happen, you need to have what's called resonance. These need to be vibrating in the same way. But once the recognition happens, the cell membrane has to interpret whether this is good information or bad information. And it has no experience with information carrying radio waves. So it interprets it as a foreign invader. So that you have this recognition on the cell membrane that occurs in milliseconds, just like that. It takes about 3 to 5 seconds for the interpretation to happen. The cell membrane trying to figure out whether this is good or bad. And it always interprets it as bad. Because it doesn't know what it is. Because those information-carrying radio waves do not exist in nature. And when the cell membrane recognizes this as bad, it sends a message to surrounding cells through the microtubules. It says, we're under attack. We're under siege. Protect yourself. We're going to protect ourselves. And one of the things that the cell membrane does is send a message that results in closing down active transport channels in the cell. And we call that hardening of the cell membrane. The permeability of the membrane is compromised. Nutrients cannot get in the cell. Waste product cannot get out of the cell. Now, because nutrients cannot get into the cell loses energy. So the cell becomes energy deficient. And when the cell is energy deficient, it's not able to communicate through microtubules. The reason is because microtubule communication is like sending a laser. It's instantaneous light energy. It takes a lot of power, a lot of energy to push that signal through the microtubule so that the intercellular communication, the rapid intercellular communication, gets shut off. So now the cells are not able to talk to each other. And when the cells are not able to talk to each other, the tissues are not able to be efficient. And the organs are not able to be efficient. And the organism gets sick. And that's why when you intervene with a subtle energy intervention, immediately you get a positive response because the intercellular communication is restored. Because the subtle energy comes in and it vibrates on the microtubules. Now, the microtubules are usually full of water. Now, in order for there to be communication, energy communication, the microtubule has to contract and expand. It has to go like that. And when that happens, there's a little hole in the water channel. And that's where the signal goes. Now, when you bring in the subtle energy from the outside, it causes the microtubule to go, and that's what restores the intercellular communication. Now, the other thing that happens is that waste product can't get out of the cell. So now you have a buildup of waste, and in that waste you have free radicals. Now, free radicals are interesting. I trust I'm not the only person in the audience who participated in the 60s. It has nothing to do with whether I inhaled or anything like that. And a free radical always likes a party. A free radical will always go where the action is. And inside the cell, the action happens at the mitochondria. The mitochondria are always having a party. That is where all of the energy from the cell is developed. It's the respiratory center of the cell. So what happens is these free radicals go to the mitochondria. They crash the party. And when that happens, the mitochondria, whose job it is to provide energy for the cell, becomes further compromised. So energy in the cell goes down more. Now, the other thing that happens is that inside the cell, you have something called messenger RNA. Now, messenger RNA is part of the genetic material. And what the messenger RNA does is it floats around in the cell, and it just is sort of like the bouncer at a party. Want to make sure everything's going fine. And if it sees something that is not going fine, it folds itself in a certain way so it can carry a message to the DNA. Now, what happens when the cell is under siege and the active transport channels are closed down? The messenger RNA take that information from the inside of the cell membrane, and they take that information to the DNA, both in the nucleus and in the mitochondria. When the messenger RNA comes in and starts to convey that information, it results in a whole bunch of pieces of messenger RNA and DNA to be unbound inside the cell. And when those pieces of messenger RNA and DNA are unbound, they're highly reactive. They are viewed by the free radicals as a party. The free radicals go, and now they disrupt the process of information transfer from the messenger RNA to the DNA. A result of that is the formation of something called micronuclei. And micronuclei are pieces of DNA or messenger RNA that function well enough to form a membrane around themselves. So now what you have inside the cell are these pieces of DNA that have formed a membrane around themselves, and they're floating around in the cell. And that would be fine, except that because the free radicals have disrupted the mitochondria now sends a message to the rest of the cell saying, I cannot do my job anymore. I'm going down. The ship is going down. And that triggers something called apoptosis. And apoptosis is when a cell commits suicide to make room for a fresh cell. And when you have that premature triggering of apoptosis, now you have the cell bursting open. And under normal circumstances, that would be fine, because the pieces of waste and the pieces of micronuclei that are released into the interstitial fluid, the river between cells, would normally be gobbled up by globulins from the immune system. But somebody's got to make the call to the immune system. And we have compromised intercellular communication. That call is never made. So now what happens is you have these micronuclei who are released into nutrient-rich intercellular fluid. And they have a ball. And they proliferate. And they clone themselves. And that is a mechanism that leads to the development of tumors. When the intercellular communication is disrupted, depending on when in life that occurs, you have different symptoms. If that occurs in utero, the symptom you have might be autism. And if that occurs during teenage years, the symptom you have might be attention deficit disorder or unexplained anxiety. And if that occurs in very late decades of life, you may have Parkinson's or Alzheimer's disease. So the disruption of intercellular communication leads to all of those clinical conditions. So that when you disrupt intercellular communication, you can lead to a whole host of serious diseases. But the situation is worse than that. Because what happens is that depending on where the cell is in its life cycle, it may not trigger premature apoptosis. The message from the messenger RNA goes to the DNA and says, we're under siege. Close down those active transport channels. And instead of the mitochondria triggering apoptosis, the cell goes through normal mitosis, which is normal cell division. And when that happens, the genetic material that was changed by the messenger RNA goes to the daughter cells. So now you have daughter cells that think that they're under siege. And then those daughter cells duplicate with the bad genetic information. And as that process continues, you have something called electrosensitivity. So that electrosensitivity is an environmentally induced genetic change. And when a person is electrosensitive, they will react in an allergic manner to any exposure to an electromagnetic field. That's why you have people who are electrosensitive who can sense a cell phone call before the phone rings. And that's why you have some people who are electrosensitive who can walk into a room and have such a splitting headache because there's Wi-Fi in the room that they can't stay there. Here's what the problem is. We run a registry in the Safe Wireless Initiative, and that registry is there to collect symptoms from people who believe they have been harmed by cell phones or other sources of electromagnetic radiation. When we began the registry in 2002, we had 1 million people visit the registry within the first 2 months. And almost all of the complaints had to do with cell phones. Almost all of them had to do with cell phones. In the past 6 months, almost all of the complaints in our registry have to do with electrosensitivity. Now, in the old days, 5 years ago, we were mainly concerned about the area 6 or 7 inches around the cell phone antenna. We called that the near-field radiation plume. And we were concerned about that because the power necessary to carry the signal to a base station resulted in a plume that had a high concentration of information-carrying radio waves. And that's why we recommended that people use headsets to move the antenna away so that they were 6 or 7 inches beyond the near-field plume, and that would mitigate the risk. Today, in most major cities in the world, the difference in concentration of information-carrying radio waves in the area right next to the cell phone antenna and the background is almost not discernible. In some places like Toronto, in the last 5 years, the concentration of information-carrying radio waves has increased 500,000 times. Now, in that effect window, where we have in milliseconds recognition and then in 3 to 5 seconds interpretation of harm, and then in 30 seconds to a couple of minutes the process of shutting down active transport. In that window, there is no threshold. What that means is that there is no safe level of exposure to information-carrying radio waves. In the lower window, where you're talking about the electromagnetic fields, the extremely low frequency coming from electrical outlets, there is a threshold. And up at the high window, where you have X-rays and gamma rays, there is a threshold, meaning that there is a level of exposure where the body's compensation mechanism is greater than the amount of damage done. But in the RF effect window, there is no safe level. That means that if you have one cell exposed to an information-carrying radio wave, it goes through that process of recognition, interpretation, and going through the process of self-preservation and protection. There is no safe level. Now, 15, 20 years ago, there were information-carrying radio waves. Remember in the old days when we used to have these TVs with those antennas on the top of the house? And then there was an antenna on the top of a mountain. And what it did was it sent an information-carrying radio wave from the antenna on the mountain to the antenna on your house. And then it converted it into some type of hardwire communication, and it went to your television. So there were information-carrying radio waves. But you weren't exposed to them because they were up in the air. Every time you make a cell phone call, you are bringing those information-carrying radio waves down to earth. Every time you make a call, you're bringing that clothesline with the clothes and the wave down to the street. And what that means is that exposure today to information-carrying radio waves is almost unavoidable. It's almost unavoidable. Now, we understand a great deal now about the mechanism of harm. We understand that there are 3 windows. We understand that the RF window, there's no threshold. We understand that the problem is triggered initially by something that happens at the cell membrane level. We understand that the disruption of intercellular communication is something that happens secondarily to that recognition. We understand that if that damage continues, that it changes the genetic material of the cell. And it carries it on to daughter cells. And that's why we have electrosensitivity, and that's why we have autism, and that's why we have those other self-propagating conditions. Now, do you ever wonder what scientists think about when they go to bed? Well, it isn't what you think. We go to bed wondering about what if we could stop that damage happening at the cell membrane level? And what if we could restore all of that intercellular communication? And if we can do that, then we can reverse the damage. We can stop the damage. And wouldn't it be great if you could prove it?